Welcome to a new Teardown video. This time it's a projector from Epson. It's called EB475WI. So it has something to do with this ultra wide short throw projection and also the interactive. So you can use those kind of interactive pens on the screen and it will activate and you can draw something and stuff. And I guess you can have this the drawings or stuff sent back to you to the users or the viewers by email or whatever. So we got a lot of different pens. This one got a button, and the other ones, they look a little bit different. So I can't wait to see how this works, how you activate this, how it communicates with the projector and all that. I've been looking a little bit on this thing. And there seems to be a camera here looking at the screen, so I guess the screen will be here. This one maybe goes on the floor or on the ceiling. And so there's like some optics and stuff in there. We've got a sensor here. We've got also a little thingy here. And it says something about focus to the left. And you can open. And then you get air filters that's like nice and clean, but this is the focus, and I can feel something big and heavy in here is moving. Maybe we can see this in the no. And on the other side there is a here it is. So this is the panel that was hiding all the inputs and outputs and connectors. Oh, got USB up here, and it's full of connectivity, HDMI, USB, and yada yada, everything, and of course mains. So what I want to do is I want to plug this in and see how it works. If I can get a picture on it. One of my friends just picked up a whole load of these. They were thrown out from some schools and stuff, and yeah, we're gonna play with them and see if they are worth any kind of funny features or whatever they can do. I better record this because you never know what's gonna happen. So I put it in here in a nice dark place. I got 230. Ooh. So this is its standby, 6 watts, 7 watts, it's going up a little bit. What? 60 watts, 100 watts. So it's definitely trying to, well, look at that. There's actually a picture on it. Haha. So far so good. There's a nice menu with all sorts of information. It actually seems to be working quite alright at this, even at this, see, super short distance. See, now we got a picture. I don't know if you can see this, but in the face of this bird, here, see, there's a pointer, and can you see that I'm pointing? Oh, no, the bird is gone. Okay, can you see the pointer here? Now they cross, and now they go upside down. So there's definitely some calibration. But see if I'm here. See if I push and hold. Yeah, I can point. I can draw something. So that is, I think this works, but there is some setup stuff. And I've been inside the menu here. Now I go into the menu, and then I go into, everything here is also upside down and completely wrong, by the way. There's no way that I can change or mirror the settings on the device. So that is also very, very odd. Easy interactive function. See here, there's something with the pen. And see, auto calibration or manual calibration. See, if I go into manual calibration, adjust the focus, yada yada yada, yes, and then we go continue to have until you have touched all markups. The final markups shown in the lower right. Calibration starts when preparation. Are you sure? Yes. See, what happens now is we should see a maybe I need to have this here. Okay, I just click. Yeah, see, there's a green dot. So I go and touch the green dot. So I think this will reconfigure. Click, and then oops, there's another one. Click and click, and then okay. So how many times do I need to do this? And how do I return? See, here's the thing. Return or press 2 seconds to cancel. Return what? I try to hit the enter or the menu. I try to hit escape. There's no way I can get out of this. I don't know how to get out of this. Escape, press again. What do I do? It's absolutely ridiculous, this shit. So I've been in here a few times before and all I did was power it all off. This is the only way to get out of this crazy menu. Damn it. I'm trying to see if there's any optical things that's going on. So at the moment it is, as you can see here, it is actually working. Right, so it's drawing some stuff up here, right? So what I'm doing is I'm looking with my camera, see if I can see any kind of light or any kind of an invisible beacon being sent back to the camera, but there's absolutely nothing this camera can pick up. So that means I definitely need to open everything to figure out how it works, because I'm not going to Google anything. I want to find out myself. That is a lot more fun. First I'm going to try and open this pen, and look, there's a tiny little screw down there. Let's see if this is the way to open it. I thought it was a little plastic click mechanism, but it turns out there was another screw hidden under this black cover, so this was not the way to do it. Only unscrew this one and just pull it that way. So I think we need to pull this that way. That is probably the correct entry. But now we're in. We got a AT Mega 168. That is the brain, and that 6-pin connector, that probably programming. So is this running Arduino? That could be pretty cool. So I think I'm gonna try and see if there's the right way to entry. But meanwhile, look. So you can do like this, and then you can do it like that, and it doesn't matter how you do it, you're gonna disconnect one of them. It's really well done, all the mechanics here with little screws and stuff. I was of course starting to pull this, but no. I need to unscrew the tip, and look what we found here, an LED. So this lights up this entire white surface, so this can be seen from all angles. But look, we also got some wires in here doing some other stuff. And what have we got up here? Some more screws. So yes, let's try and unscrew those 3 and see what happens. So now this cover here is removed, and we got some more fancy things, and those are called ICs. So what are they? Detectors of some sort? So now it's getting interesting. How is this working? Yep, we definitely got some detectors or some stuff. I think what we could do is try and boot this up and see how it works when it is like out here in the open. Maybe I can easier see what's going on. It turns out there's even a screw in the rear part with the color thing. It is really complicated. I thought it was maybe a sensor in the back. So I think when you rotate this and hit the button, you can erase. So that's how it works, right? And then you make a new drawing with the front. I still haven't figured out those. Maybe those are receivers, and then it sends back some beepity beep. so it knows where it is or something like that. I've been investigating a little bit more. This is actually an infrared filter, just like this infrared LED. And look, on the back side of those two, we got a little amplifier and a detector op amp and some stuff for that. So that means this one knows where it is in the scanned picture, because the projector will send out an infrared beacon for this one as well. So it's a two-way communication. And then the camera is used, of course, for the correct precision. So what is on the back side of this board? I see only the push button here, and the board isn't really that easy to get out. Now I'm afraid maybe there's another screw somewhere. Nope, we only got those three little Yep. So that is it. A little diode for reverse protection. A polyfuse, or yes, this is definitely a polyfuse. Tons of capacitors or series resistors, a tiny little LED. Yeah. But this switch is really made to an absolutely amazing quality. Tiny little screw contacts and gold and whatnot. Isn't that just really impressive? They can't be cheap. That is definitely for sure. Right, let's look inside the projector and see if that is also full of high quality, nicey things. So I'm trying to get into the projector unit. I just go around and remove all the screws that I can find. So this seems to be the power supply. Yeah, I guess maybe this is only the power supply for the lamp unit. It looks a lot like one of those high voltage supplies. Also, look at this connector and those wires. This is definitely for the bulb. Let's try and see if we can get this unit out. This is maybe a temperature sensor or some alarm interface, or maybe on-off. Yeah, but it's nicely EMC shielded, so that is good. So this is the power supply. It consists of two different units. The first one is, of course, the main input part and rectifier and the 300 volt DC rail, and also a low voltage part that goes to everything else via this cable. And then there's a cable to this one. And this is, of course, the lamp power supply, and this is the lamp. So it consists of 300 volt input, and then it switches to the lamp high voltage stuff. I think, yeah, this is the standard optical interface for turning on the lamp, see the lamp is running, and high and low lamp power, eco mode and whatnot. So that is a really nice unit. You can reuse. This is really good for all sorts of stuff when you're playing with the HID lamps. I think I'm going pretty good forward with all this. So there was a lot of screws, and they're all easy to find and accessible. And also I found this one screw, and then this side is slide out. And there's a heat shield, of course, so it reflects all the radiation, heat radiation from the bulb. And this is where you actually access the bulb. So I guess all you have to do is just pull this out, and then, but maybe there will be some sort of a release, something you need to push, something you need to, but it's not really coming out that easy. So I took, coming come. All the others. Ooh, we got some stuff for the panel. Hang on, I need a hand. And we are in, oh my goodness, this thing is just full of boards and wires and connectors and holy camoli, what have you got here? Even the front is full of stuff. So there was some sort of a funky sensor here. I saw that immediately. And there's some other stuff. And this is of course the beamer lens. And this is the camera. So the camera goes here, but in this area we'll have some other funky stuff. This looks like infrared, right? So there's most likely an infrared in the front, and normally you also find infrared sensors in the back or in the somewhere else, so that it will be able to detect remote controls a lot better. So this is definitely what we need to look into. What have we got here? Yeah, and this part, not even behind a infrared filter or anything, but that was of course the infrared remote control. That is completely normal. Fantastic. Now let's have a look at this thingy. This looks a lot more complicated. We've got two of them. Look at that. So you see those two chips? We got two of them. That is of course for diversity, so you can't be in the way for one, and then the other one will communicate with you. This goes up to the screen, and that means those two, they transmit and receive. See if we remove the crosstalk filter. So that is the transmitter and the receiver chip. Haha, so we got two-way data link in infrared using this board, and it was connected to that board, and it's doing exactly the same little two-way optical infrared transmitter chip. And of course this is what is communicating with this chip. So we got a transmitter and receivers. Pretty cool. So now we figure that out. This was only the buttons, nothing fancy pantsy to figure out here. Let's look at the next level here. Okay, this is of course the emergency switch. So if you remove the cover for the bulb, this will be an emergency shutdown for the bulb power. So far so good. That is good and safe, because it's dangerous if you get in touch with this kind of stuff. It's really hot and powerful, this stuff. Oh, we got a nice fan extra here for the bulb section, so that is great. Can't wait to play with the optical. See, that was the, yes. Oh, pretty cool, this mechanical interface. Oh, I was thinking about playing with this for some kind of stuff, because if I remove all this crappy optical stuff here, then I could actually maybe get a good, decent picture out of this thing, because it's making a really crappy low-res picture as well, because this is not full HD or anything. So today you can't use this for anything at all, really. And yeah, but there's a really sexy mirror in there. I was also hoping to be able to use that. And there's some more receivers for infrared remote controls. Absolutely great. This is kind of for, again, for diversity. So it will either get the direct one or some reflections one. So that means the remote control will work a lot better. Also, this camera is interesting. Is it visual? What kind of type is it? I think we got the answer to that. Look at all those LEDs, and they're hidden behind this plate. And I tried to shine some light through this, and it is so dark I cannot shine light through it. So that means it is 900 nanometers or something, even 950 or some insanely high. Oh yeah, long waved infrared. And that means, of course, this is why it's totally invisible. How cool is that? So this is what this camera is doing. Whoa, I want to power up those LEDs. And we've got a sensor here as well, right? Look at that. So it's just full of all sorts of technical cool solutions. Let me get more in here. Look at this. A lot of high power capacitors. And then the wires goes to the LED modules. But then we got some MOSFETs here to turn on and off the LEDs. So I bet they are modulating the pulses so they are in phase with the camera, and then that makes it immune to all sorts of other interferences. And if you look at the LEDs, when I move them around, can you see something? Can you see they contain multiple dyes? So that is really a funny LED as well. Can't wait to power up a few of the LEDs. That is very interesting. And the camera module itself is connected with a big nasty flat cable to a lot of good stuff, and then it's all connected via this multi-connector to the video board, some board right here. Was a connector right here. So it's not a format I would be able to access. That is real bad. It could be super fun to see what kind of picture this sees. Something tells me those guys know their EMC. See? It's a big fat connection here that connects to the speaker metal. So they don't want this to act as an antenna. And that will be the wires for the antenna. 16 watts. Whoa, it's quite solid, this speaker as well. And look, USB connections again, big fat connections to chassis. This is of course good, because this is where you come running with your USB stick and then zappity zap ESD pulse, big nasty spark, and of course you're going to reset everything if this is not designed correctly. And this is why you need as close to 0 ohm and as close to 0 inductance. And then your sensitive signals go through an inductor. So that is slowed down a little bit. So they're steering all the bad stuff exactly where they want it to go, and then they're avoiding anything bad to go and disrupt their circuits. This is how you do it. Perfect. That was a lot of screws and a lot of connectors all the way around this board. Oh my gosh, they just go everywhere. So this is the fantastic input-output section. And here is, ooh la la, this is actually our camera. Now look at that. This stinks a lot like USB. I am so much going to try and connect this to my computer and see if it shows up as a camera. Oh, this is too tempting, isn't it? Remember I talked about the USB connector cable? It is right here, right? It goes here. And the camera was here, right? So now look at this. Now I hold my finger right here. Oh, come on. See? Those we know are USB. Goes again here. And this is the camera. So that chip is a USB bridge. That's all it is. And I bet it's also connecting to all the other USB connectors. And USB things used to set up stuff. Right? See, there was one more. Yeah, look at all this. USB this and USB that, and in the front. See? Here we've got 2 more USB things here. This one and that one. And again, see? It goes straight to that IC. So that really is a USB camera. All we need to know now about the different voltages we will feed it with, and that is super easy. Have you ever heard about the fan quiz? How many fans can you find in a projector? Okay, let's have a look. Okay, now you guess something, and we're gonna see how many we can find. 1, 2, 3, 4, 5, 6 so far. I've never seen 6 fans in a projector before. I would have lost that bet. So the HID lamp, just remove these 2 screws and then it's easy to pull up. And there's of course a built-in connector in this unit. So this is something anybody can replace. And the whole design here is made with filters and all that stuff. So this lamp is nice and clean. I'm definitely going to keep this for some sort of a funny project, because this is very, very powerful and it works together with this power supply. So, and we got the power on and off and all that stuff. Super, super good. Yeah, that's definitely a fun keeper if you want to light up something. And here comes the light manipulation systems. Is really, really fancy optical stuff that direct all the light in the right way, and it goes through channels and optical stuff. And here we got the 3 different chips. So this is a 3CD device, and that is really, really good. Super, super good. You don't see them so much, and it's because this is really, really difficult to make. But again, this was a low res version, so you can't really use it today. And again, this optical kind of stuff was distorting the picture because it was a super wide, ultra close to the screen kind of system. And that is just not the way to make good quality pictures because of all this funky optical. So that is why we can't use it. And that is maybe why they threw out a whole container full. We just grabbed one of them just for the fun of it. Yeah, so this will be the 3 display drivers. Just lift that one and then we can unflippity the boards here. Yep. So we're definitely gonna dig ourselves in here and see what kind of cool optical stuff they made. Also the beam forming, shaping, all that stuff is really fantastic. Yeah, we're getting closer and closer. So that was the 3 CCD drivers, a little power supply, or just maybe just a FET with current sense on off, and a little monitor thing. Not a big deal. This is the little temperature sensor NTC, and there was one exactly like this on the power supply, remember? So of course they reused the same PCB. Let's see if they're exactly the same PCBs, because sometimes you actually see them using 2 different PCBs for exactly the same feature, just because they want this mirrored or the other way or whatever. What did I say? Isn't that funny? That's the 2 temperature sensors. And they're not even, yeah, they're not even using the same connector, right? Yeah, okay, it is the same connector, but no, it is not. Look at that. So that means they don't want you to mount this wrong. Why didn't they just make the same and just, yeah, that was dumb. So now I took out the rest of all the screws, and I think we are about look, there's a funny detail here about wires. They're a little bit too long, so they just twist the wires like this. Pretty cool way. And all fans, they are with sensors. So that would be the cable for the stepper motor. See, there's actually a stepper motor here. I'm a little bit unsure exactly what the stepper motor is to see. And another temperature sensor. And that will be the power supply input from the power supply that is, of course, mounted down here. And I think we should be able to lift up. This is Or maybe the way is, ooh, yeah. So that is the whole optical that is coming up. Maybe we should just take this up first, and then we're gonna play. I don't want to get hurt. Ooh, it's falling apart. Wow, that is something. And look at that. This Prism collector, I think is actually made of 4 pieces of glass that's glued together. Can you imagine the accuracy they need to glue this together with the 3 display chips, and then it becomes one color picture? That is amazing. So we need to look in here, and here we got a lot of beam forming. So this is where the light comes in and where they do some really fancy things. I think we can actually lift up some of the magic here. No, hang on. Also, I need to figure out how we open this, because here we will see the light actually goes in and get divided into the 3 different chips. I think we're about ready to get in here. What is it? It looks transparent so far, but I think there's a magic trick to this one. So we save this for later. I think we can pull this up now. Yeah, and here is the magic. So light comes in here and gets uniformed and all sorts of stuff. It is absolutely amazing. And then, so this is a half transparent somehow, or like a 1/3 transparent, right? So you want a 1/3 of the signals to go in here and hit this mirror and then go in here. But you also want the 2/3 of the power to go this way. And now you want half of it to go this way and the other half to continue that way, and in here. It is beautiful. You gotta love it. And you can lift up some of those. We're gonna take this up and see if we can take this mounted somehow. And I think you can also see the colorization. Yeah, you see? It changes color depending on how we look. There are actually color filters. Ooh, nice. So when this unit was mounted down here, there was actually one more thing I wanted to show. See the hole here? That is actually that fan that blows air here. Some of the air goes in and cools the light unit, and there was also the other fan here that was cooling the entire lamp unit. But it's also important to get a lot of air through the beamformer system here, because otherwise this is going to melt down. Imagine we got 200 watts or even more of light going straight through here, and all this glass will of course get very, very hot because there is a little tiny bit of loss. I'm gonna see how we can pull this apart. And now with the picture unit removed, imagine it was like this. Also, what you see here is how they handle the thermal problems or the challenges. Some of the air goes this way up here and cools something, and then it goes to the 3 CCD modules. It's just fantastic to see how much brain power they put into solving everything. And this one is of course good electrical connection up to all the metal parts here. We want good solid electrical connection to everything, of course. This will be a mains input filter section. Let me see if I can pull this more apart. So let's see, I took out all the screws. So I guess, yes, that was right. That is the mains input filter, mains fuse, and see, even a little ferrite for good filtering. This is stuck. Anyway, so that was the mains filter. Still got some. That will be connected to the temperature sensor. This is the tamper or the lid open for the lamp supply. Or this is actually for all mains supply. See, all mains go through this one, and including a meltdown fuse. I think this one is actually the ones that will go open and stay open if this unit was overloaded to a degree just before meltdown. So of course they want to fireproof stuff. It's not a good reputation to have a house burning down because of this unit, so of course they're protecting themselves. Look at all the thermal intelligence that was put into this. It is just amazingly well done. All those fans mounted in all sorts of fancy ways. And again, this unit didn't run for that many hours. I think it was 1200 or something like that. I checked the lamp hours. So that means all those fans, they're perfectly fine for all sorts of things. I can really use them for all sorts of cool projects. So that is super, super win-win. They're really, really nice. And they're really powerful. This type of fan can do a lot. See, there's no dust or stuff in it, but of course it had a filter at the inlet and it was quite dirty. I just cleaned this filter. So yeah, that is exactly what they did. So now we're gonna play with the optical stuff. I look so much forward to doing that. Actually a little bit funny. This is the filter that goes to those two, right? But see, it's actually made so light goes in and gets reflected on it and becomes one color, and the light that goes through it becomes another color. So I don't know if you can see this, but this is one way. And if I flip it the other way, see? Isn't it a different color? This is one way. This is the other way. No, it's exactly the same way. But this is, I think, it depends when it comes to transparency or reflections or something. So this is one kind of reflection, or this is the other way. Yeah, I think there is a difference. It's different. I think this is difficult to explain because I really can't show this on a camera. And the other one, of course, works a little bit the same way, right? It's super, super clean, the colors that it becomes. That's so much fun. So that gotta be it, because I can't see any other filters for the last one. Now I figured out what the stepper motor is doing here. It's actually opening and closing for the light. That is actually quite funny. Why would you do that? So a stepper motor here is, yeah, pretty cool. We got two of them. A mechanical open and closed. Weird. Oh, I took off the first lens. Look at that. So it's actually a Fresnel. But it's not. Multiple lenses. Really, really funny. And then we got another one that is a little bit different, but now it's easier to see the open and close mechanism. And it's actually going so it can close it completely. Wow. I'm of course saving all the optics because it's really, really useful when you want to read text on ICs or any small things. Super good with the optics, but look at that. So those are two polarizers. See, now I'm going through them in the right way. See, if I swap, there's no light coming through. Then we see the camera and the distance sensor. And now it's open, close. And doesn't, if I only have one, there's no problems because this lens is not. Let me put it all the way to the lens. But now it's actually on the lens, isn't it? Is it that? Where is it? So if I put it, yeah, you go straight through it. Open and close. How cool is that? And this is very useful for putting on your camera, and also put on some light, and then you can make magic when you want to see something. So I'm going to save those for some later experiments. That is really odd. So remember I said first we got a Fresnel, and then there's a really weird lens. Look, it's actually made in triangles, and they're glued together like this, and we even got some metal here on the back. What the heck? So this is beam forming or splitting out the light in a special way together with this lens. What the heck? That one I haven't seen before. Yep, you can see it up here. It's made of some sort of triangles or something like that. Maybe let's see. Or some layers. What the heck is that? I am not educated within the optical field. But this is definitely something funny to play with. I'm gonna get a flashlight and play with this, or laser or some stuff. This is gonna be fun. Damn it. Getting the last Fresnel lens out without damaging it is like really difficult. So I had to crack all this plastic, but it's going to be trashed anyway. But this is intense. This plastic is so much glass filled. It is almost becoming glass. But I think, see? Oh, I think. Oh, come on. Oh, yeah, I got it. Because those are really funny. But now I got two of them, and they're a little bit different. I think I can maybe do some funny things with this. See, there's some kind of magic that happens when they are in a special distance. I'm gonna play with a flashlight and make some really cool things with those two. Definitely. Oh, you gotta see this. See, I have my hand here in front of this, and I put light in the reverse order, and of course we get a picture. And then the picture becomes in 3 different colors. Let's see the other one. Of course I can't do that because it's the other way around, right? Hey, blue picture. Green, ooh. Yeah. And this is probably red, right? It looks a little bit orange to me. But anyway, this is how it works. So there's some kind of a color filter or something in here. Oh yeah. I think we can not really get in here. See, I did actually manage to get in. Now I'm looking out. So if light comes in the back or left or right, it's definitely different colors going through this prism. Oh, see, they wrote some arrows down there. Pretty cool. Just so people can know how it's assembled. And also we see not only we got the picture chip. We also got a polarizing filter. I was pulling up one of the polarizers, and this here it's gone because I took it away. See, I took off the 3 display chips. Now you can see fingers in 2 different colors mixing up. That is pretty cool. I'm gonna love playing with this color prism thingy. And look, the 3 different screen modules. Of course they mark them with red, green and blue. And of course they're quite transparent here. The little picture is actually here. Yeah, they're quite sexy. Just if you want to know if you could go even further into this. See, the glue that they're using isn't really super strong. So, see, so it is possible to go all the way into the fantastic yeah. I really don't want to scratch it. I really want to keep it as beautiful as it is. And I think this is actually a polarizer film that is mounted here. I don't want that because I want to have them as nice and as transparent as I can possibly get it. Yeah. Because it's a lot of fun to see pictures in different colors mix. Oh, it even we even got glass here on the sides that is glued. Damn it, I can't get that off. I think we're gonna keep it as it is now. It sets on a little, it's even glued on this one. This I think I cannot get off. I'm just gonna get hurt. And this is definitely also on my list of stuff I really wanted to play with. Maybe we can get this mirror out and do some really funny experiments with this. I was expecting it to come out. Aha, so this is mounted. How the heck is this? So it looks a little bit like, yes. What? It's just plastic? That is just sad. I wanted it to be high class glass, so maybe I could make a telescope or some funny thing. But it is really nice. Why is it so difficult? It is not meant to be. So that is out, okay? Why won't you just... So there's some sort of an arrangement for adjustments and... Oh, those are springs! Okay, fancy pantsy stuff. So it's mounted in 3 points up here and here and here. So we can do some adjustments and stuff. Okay. What do you know? We're learning by doing here. Are you coming out today? Ooh, Let's see if we can focus on the camera and get it to. So that is a really, and when I look at it like this, ooh, That is really sexy, and it's very, very thick. I'm definitely going to play with this in the sun, see if we can do some damage. Great. Let's play with this stuff. So all the lenses here are really funny, and of course they... Ooh, I can see some... So they're compensating and doing also some magic to match this mirror, of course. Ooh, and we got a... Somebody's writing some secret messages here. This means I had cheeseburgers for lunch. That's what it says. There's a screw in here. Look at the lens. It's really, really weird how the line is just completely off center. So all the lenses are here because they wanted to do some funny stuff, and this will be the focusing. It's not really moving a lot. I think it's because it is in a super critical position, so it's just not doing a hell lot. Yeah, but there isn't a lot of fun to see in here, and I thought this could have been a lot more fun, but this is super boring. Hey. Haha, the lens could just be screwed out. And what do you know? This thing is actually a microscope. See what happens if I put this on the camera? Now I hold it here, and now I put my finger in the front. Look at that. That's my finger. That's crazy. So we got a microscope. Yay. Cool. That's definitely a keeper. So I think this is how it's... Ooh. Oh, this is definitely... See, this lens is the funky, funny fix there. The curved lens, kind of optical deformation back to normal. Crazy, wazy. And all other lenses, they're just nice and normal, and they can do all sorts of fancy things round lenses can do. Well, there's not a lot of good things in this one, right? Only a tiny bit, and then there's a lot of good in this one. And by combination we can do... Yeah, well, anyway, optics, that's just a fun thing for funny. I tried to splatter a lot of dirty fingers on this lens so you can easier see the plastic, the curves in the plastic. They are really, really funny bend. So this is the magic in making the picture good. Oy, oy, oy. Who did the magic calculations, ray tracing, yes, sculpting? I'm trying to get all the different fans out. And it turns out that almost anywhere I look, I keep finding those temperature sensors. So they're monitoring airflow everywhere. It's amazing. And that will be the fan score. Really, really nice fans, all of them. And different sizes, 3 of the same size, and then a bigger one and a smaller one. So this is the camera module. I'm playing a little bit more with the light modules, and it actually seems like we got some different wavelength of LEDs, especially the small one here. That looks a little bit like a completely different type of LED. And then there was this little light sensor. So what I did is I took off the lens system for this, and sure enough, there's a little motor system and variable filter. So that means by moving this one, bzzz, see, now the camera can see visual light, and then bzzz, back, and it can now see a secret infrared wavelength only. That is really cool. So this is the camera board. It contains a muscular FPGA for the camera, and oh, look at that one. So that's the microcontroller that's handling all this. We got some memory, we got some level conversion and stuff, but that's actually really crazy. So I guess this is returning all the coordinates by USB. I didn't expect it to be that cool. Technical stuff, man. So that is what they did. And they also put in a really solid copper connection between the two boards. So we got a really good EMC shielding for the camera module. And also a ferrite. So this is the back side of the camera module. A tiny little stepper motor here. This is the one that's changing between the two different filters. So that's all we got. Doesn't say anything intelligent. So now we had great success disassembling the Epson pens. So hey, let's try and look inside the Sony pen if it is just as easy. The battery seems to be a little bit over last use time. Ooh, look at that, gross. But it did not infect the unit yet. The only screw that I can find is that one. So, but what I learned from the other one was the tip needed to be, yes, that was right. Oh, look, that is a transparent LED. That's pretty cool. And then, yes, we got 3 tiny little screws up here. Let's have a look if this is the way. So the tip came off quite easily. I think, yeah, okay. Ooh, look at those tiny little wires for the LED. And then there's a switch, a normal switch, and some more wires and stuff. Okay, so the whole unit comes out like this. Why have we got that many funny wires and some... Okay, so that will be, look, adjustment screws. So that means it pushes this PCB, including this switch, up for alignment. Let's just pull this out. So that's all it does. Yeah, the other 2 wires, that will be for that one. So the only thing we got here is a, let me clean this up a little bit more first. So that is really it. The LED and a switch and a PIC 12F something, it's impossible to read. A little voltage regulator and a little other thingy and 3 transistors. That is it. So it's probably using the LED as detector as well. Well, that's pretty cool.